Hello class, this is Miss Augustine, and today we are going to do some practice mole calculations. Specifically, we're going to work on mole to mass and mass to mole calculations. So, first, let's remember what molar mass is. And molar mass is the umbrella term that we use to describe the mass in grams of 1 mole of a substance. And the molar mass can be the equivalent of gram atomic mass if we're talking about elements, gram molecular mass for molecular compounds, and gram formula mass if we're talking about ionic compounds. So depending on what your substance is that you're calculating, we have different names for it. Is it an element, a molecule, or an ionic substance? But the easiest thing is to just refer to it, as I did up here, as molar mass. So the first example is going to be specifically calculating molar mass, and we're going to calculate for a molecular substance, ethane. Calculate the molar mass of C2H6, which, as I said, is ethane. So first you'll pull out your handy periodic table, and you'll look up carbon, remembering that you have to round it to the hundredths place. We always round from the periodic table to the hundredths place. So in this case, 2 times carbon is going to be 2 times 12.01, that comes out to 24.02 grams. And then for hydrogen, which is our exception, in the case of hydrogen, we have to use the thousandths place. It rounds to 1.008. So 6 times that is going to give us 6.048 grams. And then we'll go ahead and add that up, and we'll see that we get 30.068. But remembering that we always round our molar mass to the hundredths place means it will round out to 30.07 grams, which is equal to a mole. Now, looking at our mole roadmap, remember that we can get at it 3 ways. We can get at a mole from volume at STP, and from the number of representative particles, atoms, molecules, formula units. Those will be at a later date that we'll work on those. And for today, we can get back and forth between moles and mass using atomic or molar mass. So our first calculation for mole to mass or mass to mole is going to be a mass to mole. Given mass, how many moles? So specifically given 41.0 grams of ethane, how many moles does this represent? We calculated previously that the molar mass of ethane is equal to 30.07 grams per mole, and that 30.07 grams per mole will be the basis of our conversion fact. So to calculate the number of moles, we always begin calculations with our given, here 41.0 grams of ethane, and then we're going to multiply by our conversion fact, and that is that for every 1 mole of ethane, there are 30.07 grams. We need to cancel our units, so we'll see that grams of ethane divided by grams of ethane goes away. That's going to leave us with moles of ethane, which is what we're trying to get. And when we plug it into our calculator, we get this big number with all these digits, 1.363485201. We know that we have to round to the correct number of significant digits. For that, we look at our given, which was 41.0. That represents 3 significant figures. So you'll see that I underlined, counting from the left, the 3rd significant digit is a 6. So that means we look at the number immediately following it, 4 and below. You let it go, that's a 3. So again, ultimately, we will round this to 3 significant digits, and it will be 1.36 moles of ethane. The next calculation is going in the opposite direction, going from moles to mass. So given 2.50 moles of ethane, how many grams of ethane would this represent? The molar mass, as we stated, is 30.07 grams per mole. To calculate the number of grams, we're going to always start with our given. We're going to multiply by our conversion fact, and right here our molar mass is our conversion fact. So 2.50 moles of ethane times our fact, 30.07 grams for every 1 mole of ethane. And then we'll notice that moles of ethane divided by moles of ethane cancels out. That's going to leave us with grams, and that's what we're trying to get. And then you'll notice here that we started with 3 significant digits, so I have underlined the 3rd significant digit, recalling that we always begin counting from the left. And then I have noticed here with an arrow noted that the number immediately following our last significant digit is a 7, a 5 and above. You give it a shove. That means we're going to have to round up our 1 to a 2. So rounded, our answer will be 75.2 grams of ethane. So given 2.50 moles of ethane, that represents 75.2 grams of ethane. So again, what we did today is go back and forth between grams and moles, and our conversion fact that we use is going to be molar mass, and you calculate that from your atomic masses. The next slideshow that I will do with you will show us how to go back and forth between mole and volumes, and then we'll finally go between mole and particles.